Greetings everyone, I'm Tamhidu and we're Team WWTP, what also stands for War Waged Against Troublesome Plastic. What we do is bring to you a cost effective, utilitarian, and extremely sustainable plan for water treatment. The reason we chose the name is that we have a device WWTP capable of removing microplastics from industrial wastewater and municipal sewage before releasing them into the environment. Before we go any further, let's get introduced to the other members of our team. We have Shomik Paul, Onik Day, Ayman Wadud, and lastly Ritik Boria in our team as well. Now let's begin with what microplastic is. Microplastics are most commonly defined as plastic particles which are less than 5 millimeter in diameter. They're either manufactured or results from breakdown of larger plastics. The figure on the right shows how these particles end up in the ocean. Microplastics cause chronic toxicity in marine animals and pose serious health threats to humans due to biomagnification. Several studies have confirmed the WWTPs are the key players in releasing microplastics into the environment. Moreover, sludge mismanagement adds to this land spread pollution. Our solution to the microplastic problem is focused on upstream intervention. Imagine your basin is overflowing and you got a mop and a basket to clean it up. But what's the point of mopping if we can't turn the tap off? Similarly, instead of cleaning the ocean, we plan to retain plastic waste using cost effective and efficient technologies and use the waste as currency to create a sustainable economic cycle. Here's an overview of how we plan to do it. We will use bar screening and a horizontal flow grid chamber as preliminary treatment. Then a primary clarifier will be used to sediment larger waste particles. Rotating biological contactor will perform the biological treatment, and then microplastic removal will be carried out by microplastic removal plant. The resulting sludge, free from microplastics, will be separated and eventually undergo anaerobic digestion. On the other hand, plastic waste will be pyrolyzed for fuel production. First things first, wastewater analysis is essential for the optimization of WWTP units. Since shape and abundance of the microplastics can affect removal efficiency of WWTP, microplastic detection, sampling, and identification are needed for optimization of the procedures. This is our pumping device for extraction of wastewater, as you can see. A customer-made has been used to sample wastewater, which will then be taken to lab for analysis. We will use zinc chloride solution for sample pretreatment and microscopy for identification. Subsequently, we will weigh the microplastics using an analytical balance. Here's the overview of the whole sampling, pretreatment, and identification process that we have just discussed. For secondary treatment, we will use a rotating biological contactor. This technology removes organic matter from wastewater with the aid of microorganisms. Rotating biological contactor is a promising technology owing to its easy operation, low cost installation, and bulk resistance feature. It is also very durable and reduces a significant portion of the sludge volume. Our microplastic removal plant, or MRP, is a novel addition to the WWTP. It features a cost-effective Whitman membrane filter and an innovative backflushing system. The figure on the right shows the simplified structures of our MRP. Our MRP has been optimized in such a way that it can effectively filter microplastics all the time. During filtration, the influent passes through the membrane filter, and approximately 99% of the microplastics get separated from the effluent. The backflushing system ensures that they end up in the sludge container instead of clogging the filter. Our MRP is exceptionally effective, costs lower than existing membrane processes, and overall is a better choice than the other microplastic removal technologies. Another cornerstone of our project is the Sludge Management System, or SMS. SMS is our holistic approach towards utilizing all sorts of sludges produced in the WWTP. The multi-stage treatment separates the plastic wastes from the non-plastic wastes. Ultimately, this sludge is anaerobically digested and produces biogas, digested and reject water. The flowcharts schematically represent this process. Out of three products of anaerobic digestion, digest is considered a waste and is either landfilled or used as a fertilizer. However, it often contains microplastics and leads to plastic pollution. Thus, we have come up with a solution that successfully utilizes digested without putting the environment and others at risk. Our post fermentation bioconverter can transform this waste into biofuel with the heat of combustion that is comparable to that of the traditional fuels. Now, one you might think, well, your proposal works on paper, but is it really practical? To answer that question, we have included here a cost and profitability analysis of our bioconversion process. Considering everything, it turns out that we can save more than 60 euros per megagram of our bioconversion product. This also means that there will be zero waste in the whole process of anaerobic digestion. Besides, the biogas produced from digestion can provide about 50% of the operational energy of the WWTP, further reducing the operational cost of the plant. On the other hand, all sorts of plastics will undergo pyrolysis and add to the energy output of the plant. To conduct an economically feasible pyrolysis, we'll supply additional plastic wastes procured from local collectors. This in turn will also reduce the land-spread plastic pollution while simultaneously being a continuous source of our income. For our pilot program, we hope to process 10,000 kgs of plastics per hour. From the cost analysis, it was found out that about 0.05 euro was required for each kg of pyrolysis fuel production. On the contrary, the sale price of the fuel is 0.62 euro per kg. This huge difference in terms of profitability gives the payout period within only 1 year. Thus, a plant with a lifetime of 20 years can generate revenue in the range of 38 to 93 million euro. SMS is a powerful system that excels in comprehensive waste and energy management. It can convert all sorts of waste into energy and consequently remove the need for landfilling and transportation of waste. Alongside the environmental benefits, SMS can also provide the WWTP with economic benefits as well. The excess energy that is produced can be sold to corporations or grids for a huge amount of money. This cut in operational costs, coupled with sustainable energy production and profit, makes the WWTP a self sufficient, environmental friendly unit. Why customers are going to prefer this model for the treatment plant? Well, the two main features of our product is cost effectiveness and efficiency. In the current market, industries normally see our product as a burden as do not generate any profit for the firm. However, for WWTP, we created a model which shows that sludge generated in WWTP will be treated in two different ways to produce energy, which can be used to power the WWTP and the surplus can be sold to the grid. Thus, profit is generated and at the same time a sustainable management system for sludge is created. Moreover, our company planned to buy plastic waste from the local plastic collectors, which we will then use in our pyrolysis plant to generate fuel. So it will also help recycle plastic, thus generate a zero waste system. We have also done a SWOT analysis to help us build on what we do well, to address what we are lacking, to minimize the risks, and to take the greatest possible advantage of chances for our success. We have discussed our core project so far, that is a full-fledged blueprint. As a part of our product, we will also provide service and troubleshooting on demand. Now, how do we plan to take it to the market? Our pilot program will be initiated in Bangladesh to assess the performance of our product and develop it. We have short and long term milestones, which primarily include getting credibility and expanding our market territory gradually, from districts of Bangladesh to South Asian and Sub Saharan African countries. For our constant revenue source, we have the price of blueprint, manpower, research ops, price generated through utilization, and reuse of waste materials. For our over expansion, we consider government project funding and budget allocation, rent and hire opportunities, paid consultancy, and revenue from sharing research data. Research costs, labor costs, licensing, bidding, and expansion costs are the main expenses of our project. This is our business cycle flowchart where we have shown how we will gradually open up our business. According to World Bank Report 2019, South Asia, ranking third globally, generates a staggering 334 million metric tons of solid waste everywhere. Between 70 and 80% of this ends up in the ocean, and most of it is plastic. What's encouraging though Team WWTP is dedicated to make a radical change in this sector and redefine the concept of WWTP, combating plastic pollution at the same time. Thank you very much for your time.